So, welcome to the lesson on probability simulation. So a simulation is something that we can do in the classroom that represents the reality of finding the probability of a real life situation. Okay, and we design them so that they closely resemble what is happening in real life. Obviously it has to depend on chance, it can't just be any old thing. So we can use various number of tools. We can use dice, we can use random numbers, we can use the little spinners, we could use coins and represent them by flipping, and we can also use playing cards. And I'm going to show you an example of a simulation that I've done here. When we go into the classroom, or when you come into the classroom, we are actually going to be doing a couple of different simulations, mainly using random numbers, but we'll see, okay, and you'll enjoy those, hopefully. So here's my simulation that I've done, okay, so we're looking at a small firm that's got several computers that run constantly. And this is often something that's put in a question. Describe a simulation that could be used to estimate the probability that the next 2 times a computer breaks down, it will be outside of working hours. Okay, and it says here in the question that 9 till 5 are working hours. Well, we need to elicit some of the key points from that question. So 9 AM to 5 PM is 8 hours. Okay, so that's 1/3 of a day that the office is being used, and that is deemed working hours. So what we're going to do is we're going to use 2 dice, and they're going to represent the 2 breakdowns. And on the numbers on the dice, we're going to let numbers 1 and 2 represent the working hours, and we're going to let 3, 4, 5 and 6 represent the outside of working hours. Now the reason we've done that is because 1 and 2 make up 1/3 of the total numbers on the dice. We could have quite easily used 5 and 6 or 3 and 4, but I decided to use 1 and 2. And 3 and 6 are obviously then going to be the outside working hours. So I'm actually going to get you to do some work now. So what I'd like you to do is, once you've finished watching the video, is actually do this experiment for yourself. Okay, now if everyone does that, we should have some really good data when you come back into the classroom. So what I want you to do is find 2 dice and then throw the dice a large number of times, okay, about 100, okay, and you need to record the results in a table. Now this is how I suggest you do your table. So we have a trial number, always handy to have that because it means we can keep track of how many we've done. And then I want you to record the result of the first die even, and the result of the second die. Okay, so I did a couple of experiments and I got a 2 on my first one and a 5. Now are both of them between 3 and 6? Remembering that between 3 to 6 was our outside of working hours. So no, they're not, because the first die happened during working hours, the first breakdown. I did trial 2 and I got a 1 and a 5. Okay, and again, not all of them are between 3 and 6, so again it doesn't count. And I looked at number 3 and I got a 4 and a 6. Well, they are both between 3 and 6, so that counts as both computers broke down outside of working hours. So what I'd like you to do is to carry on doing that for 100, record your data. Now when you've recorded all your data, what I want you to do is count the number of times both die, I should say dice, are 3 to 6. And this gives us the estimation of when the next 2 breakdowns will occur outside of working hours. Okay, and we can work that probability out. Okay, outside of working hours equals the number of times we get both dice get 3 to 6 over the number of trials. So for my one example here, I've got 1 out of 3, so it'd be 1/3. However, quite clearly, I don't have enough data here. So what you need to do is make sure you do have enough data in order to do this experiment. So stop the video in a minute when I've finished talking. Go and do the experiment. If you need to rewind it, obviously you can do that quite easily. and please remember to bring your data into school. Thanks.